let's tie together a couple concepts from a couple of different places. So in a hypothesis testing, what we're essentially doing is we're assuming something. And then if we have a 5% alpha at our usual significance level, it's basically just us saying, if the odds of this happening are less than 5%, then we're suspicious. Another way of doing that would be to use p hat to generate a confidence interval. Because if the proportion from the assumption is in the confidence interval, that's essentially saying there's a 95% chance of happening if everything's working as expected. Well, then 95% chance, yeah, no, we're not going to reject the null. But if the proportion from the null hypothesis is outside of that confidence interval, which will only happen 5% of the time, that's when we reject the null. So that's basically exactly what we're doing with hypothesis testing. If the odds of this happening are less than 5%, we reject the null. If we're outside a 95% confidence interval, there's only a 5% chance of that happening, so it's really the same thing, basically. There's some small distinctions, but it's basically the same thing. Let's get some practice with that. In 2008, the Center for Disease Control and Prevention reported that 34% of adults in the US are obese. I wonder what it is today. A county health service planning a new awareness campaign polls a random sample of 750 adults. Okay. 228 were found to be obese. Construct a confidence interval and determine whether this provides strong evidence to say that the 34% obesity rate is not accurate for this region. So remember what your confidence intervals look like. Your confidence, see if I remember, it's been a few weeks since I've done that video, like a month or two actually. Your confidence interval is just take your sample proportion and add or subtract your critical z-score times your standard error. So we need to find all these things. What was our sample proportion? We had a sample of 750. 228 were obese. What proportion is that? 228 over 750. That's 30.4%. So again, I know that 30% is smaller than 34%. We're trying to say, is this far enough? Is this smaller enough? Is this significantly, statistically, I can't say that, statistically significantly smaller than the national average? Or did we just get lucky with who we surveyed? Can we really claim this or not? We're going to use confidence intervals to do that. So if that's the case, what is Q hat? Q hat's just what's left over. P hat is what proportion were obese in our survey. Q hat will be what proportion weren't. It's 1 minus P. 0.696, I believe. N, we already said, was 750. What's our critical z-score? Well, for a 95% confidence interval, 1.96. So then our confidence interval becomes P hat plus or minus z star times the standard error, which is the square root of 0.304 times 0.696 all over our sample size of 750. And we'll just type that into a calculator to get our interval. When we do that, it's going to look like this. Let's do the minus one first. Being very careful that how we type it in is how we think it should be. So 0.2711, 27.11%, up to, let's change it to a plus to get the bigger one, 0.3369, We're 95% confident. Let's remember what unit 6 looked like. We're 95% confident that the proportion of obese adults in this region is between 27.11% and 33.69%. That's what confidence intervals are all about. So it said construct a confidence interval. We did that. And now we need to answer this part of the question. We're 95% confident that it should be between this region. So if the claim is 34%, notice 34% is outside that region. 95% of the time, we would expect this to be inside. This doesn't prove that there's a difference, but it makes us suspicious. If the proportion from the null hypothesis is outside the interval, and again, our null hypothesis here would be that P is 34%. So it is outside of the interval. It is outside of the confidence interval. This is essentially saying that our alpha is 5% and our p-value is smaller than 5%. We're outside. We will reject the null. You could go through the steps, create your null hypotheses and stuff like that. And once you do that, you're going to say there is enough evidence to reject the null. Is enough evidence to say the obesity rate is different in this county or in this region compared to the national average. So that's how we can use confidence intervals for this. We won't do too much with this, but it's cool enough to connect the concepts and see how they're essentially the same idea, confidence intervals and hypothesis testing. But I'm not going to spend too much time on this because it's really just a small piece. And all the other pieces, and there are many, all the other pieces of Unit 8 are more important. Let me know if you have questions about this. I know this whole unit is really confusing. There's so much going on. Every time I teach it, I try to teach it a slightly better way because it's a process. Okay, so if you're confused, you're not alone. Ask questions. Good luck. Bye-bye.